So we're going to look at a big question, and the question is, what numbers exist? So I've never seen a 2 in a field before. So how do I know that a 2 exists? Well, these are great philosophical questions about where mathematics come from. Do we discover it? Do we invent it? All good things for you to look into. In terms of your mathematics learning at school, you certainly do need to know about which kinds of numbers exist. And the way that it generally gets introduced is in what's called set theory when you start to learn about sets. So a set is just a collection of objects, and we consider numbers to be objects just like anything else. Although they have some special characteristics or interesting characteristics, they're not like a chair. But in any case, let's jump into it. Let's look at this. Let's start with some small sets of numbers. One of the smallest sets of numbers that we can consider is what's called the natural numbers. We use a capital N for natural numbers. That's a number like the number 3. It would be a natural number. All countable numbers that are greater than 0. Now that's up for debate. Sometimes natural numbers include 0, sometimes it doesn't. So you just need to specify and be clear. But 1, 2, 3, 4, 5, 6, all those numbers up to infinity would be the set of natural numbers. Okay, a larger set than that, I think you would agree, would be what's called integers, and we use a capital Z for integers. That's going to include all the negative numbers, right? And it's definitely going to include 0. So it's all whole numbers, positive and negative. So -1 and 27 are both examples of integers. You can see that 27 would also be a natural number, right? But it's also an integer. So we're sort of getting these overlapping circles going on here. All natural numbers are integers, but not all integers are natural numbers. Okay, let's keep going. The next set that's larger than that are what's called rational numbers. So rational numbers are any number that can be expressed as a ratio. So the key is in the word there as a ratio. So 1/2 would be the ratio of 1 to 2. So it's considered a rational number. 0.75 is 3/4 as a fraction. So that would be a rational number, can be expressed as a fraction, can be expressed as a ratio. Okay, all integers and all natural numbers are rational numbers, because if I take the number 27, I could express that as a fraction, as 27/1. That would be the ratio of 2 integers. So rational numbers, one way to think about them is, it's going to be a larger set than integers, but it's going to include things like 0.5. That isn't a whole number, but it is a rational number. Okay, next one. Now we're getting a bit more interesting. Then we've got real numbers. Okay, so all real numbers. So real numbers, it can include rational numbers, integers, and all natural numbers, but they also include things that are irrational, like the square root of 3. Okay, so that is on our real number line. If you think about your x-axis, which you've certainly come across, that is our real number line. It includes every number. Okay, this is a fraction, but it's not a rational fraction, because the square root of 3 itself cannot be expressed as a ratio of 2 integers. So although this is a real number, it's not a rational number. Okay, within the real numbers, we've got another subset, which we call irrational numbers. Okay, these are numbers that cannot be written as a ratio of 2 numbers. So this is an irrational number, but it's also a real number. But these are just classic examples of irrational numbers. The square root of 2 cannot be expressed as a fraction. Pi also cannot be expressed as a fraction. Okay, so if you want to get really technical, there's what's called algebraic and non-algebraic numbers. The square root of 2 is the solution to an equation. So that's what's called an algebraic number. Pi is a non-algebraic number. You cannot find pi by solving any kind of equation, any kind of algebraic equation. So it's what's called a transcendental number. Anyway, you don't need to worry too much about that. So, all right, let's keep going. Next one is the grand finale. We're looking at complex numbers. Okay, so complex numbers is the largest set that we're aware of. I'm sure on the internet somewhere there's other sets, but this is all you need to know for high school anyway. Complex numbers is the largest set. Okay, so this is an example of a complex number, 2 + 3i. Okay, this is what we would call the real part of the complex number. This is the imaginary part of the complex number. So within the complex numbers, we've also got what's called purely imaginary numbers or just imaginary numbers. So this is things like the letter I. I is the square root of -1, okay? And then I root 3 would just be the square root of -1 times root 3. So these are all the numbers that you need to be aware about. I just want to point out one more thing, which is this notation here, this symbol. It's kind of like a curly inequality sign. We could say the following, right? We could say all natural numbers. This symbol here is that it means a proper subset. So all natural numbers are completely contained within the integers. Then all rational numbers, sorry, and then all integers are contained within the rational numbers. Okay, then all the rational numbers are real numbers, and all the real numbers are complex numbers. So we'd say N is a proper subset of Z, is a proper subset of Q, is a proper subset of R, is a proper subset of C. Most of what you do in high school maths, unless you're doing specialist maths, in Victoria anyway, you will be in this purple circle, purple ellipse, because most of mathematics that you study at high school level is to do with real numbers and all these other numbers that are real numbers. So hopefully that explains all the different kinds of numbers. Good luck.